Alright, this video will cover the quartz rich or quartz sandstones. You already met this one. This is the one that is almost entirely quartz. We see almost nothing other than white grains in here. Now it could be tan, light tan, or kind of like this color here. It is not uncommon for quartz sandstones, but I happen to have collected almost entirely white ones, so that's what we're going to look at. These ones here are mostly white in color. There are some other grains, this one more so than these two. These are, notice they're not very well cemented, so we often describe sedimentary rocks as how well they're cemented. This one is not very well cemented. I can literally break it into its original sediment, just the sand grains. This one here I cannot do that too, so this is well cemented. And this one is even better. This one is so well cemented you can barely see or barely feel any grittiness. This one's still pretty gritty. This one's pretty smooth. It breaks very, very smoothly. So that probably means that each one of these grains is cemented with quartz, and it's so well cemented that when it broke, it didn't just break around the quartz grains, it broke through the quartz grains. So it ended up being a very smooth rock. So this one is also pretty friable or easy to break apart. So it's not terribly well cemented. This would weather away very quickly. Same thing with this one. Also, I can pretty much break it apart. These are part of the Wislet Formation from Huntsville. Now this one has some other colors mixed in, so we would have to be very careful calling this one a quartz sandstone. Because it has some other grains in there, then we have to carefully count. Now, how would we count this, you might ask? So the way in which we actually determine volume amount, so the percentage of grains, is we make a thin section, which means we trim this down on a saw to about 1 inch by 2 inches little piece of rock, glue it to a glass slide, trim that down, and then grind it to about 30 microns in thickness. At that point, we can pass light through the minerals, and we can identify them using optical techniques on a special kind of microscope that will allow us to be able to identify different types of minerals by simply looking at them. At that point, we would have a grid system set up where the slide would be moved across and down and back and forth in a grid pattern that would allow the crosshairs to land on a different mineral, a different grain, each time that the slide was moved, and we would identify that grain and count it. And we would do about 600 a slide. So that means we would go through and hit the button to move the slide over on this grid pattern 600 times, count all the grains. You have one of those little tickers like they have at theme parks. When they count how many people they are, they click them down. And you would count, okay, it lands on a quartz grain, 1 for quartz. Lands on another quartz grain, 2 for quartz. Keep going. Maybe it lands on a rock fragment, like these black ones are probably rock fragments. Then we would add 1 for rock fragment. Maybe it would land on a feldspar. We'd add 1 for feldspar. And we do that all 600 counts. It's very boring. But sometimes science is exciting and sometimes science is very boring. And we would then at the end have a 600 counts, and we would divide each of those minerals by that 600 count total, and it would give us a volume percent. And if we had 90% quartz, then we could call it a quartz sandstone. Otherwise, we might say it's a quartz rich sandstone rather than actually a quartz sandstone. This one is from the same formation, the Catahoula Formation, and notice that there isn't much else in there. It's pretty uniformly white, so I would feel pretty confident calling this one, even just visually, as a quartz sandstone. And this one is also from the same formation, pretty white, and gritty. I would call it a quartz sandstone. Now notice that this side. This is the weathered side. You always have to be very careful when you're looking at rocks that you look at a fresh surface, because The weathered surface might have a layer of organic stuff growing on it, lichen, mildew, moss, something. It also might have some of the minerals that aren't quartz in here may weather in such a way that they leave a discoloration. So we want to be very careful to look at a fresh surface rather than a weathered one. So those are the quartz sandstones.